Hello, chemists. We are going to be moving from our work on how experiments are done and the scientific method into some more specific chemistry stuff with rates of reaction. So rates of reaction is a term that I will define in just a moment. By the end of this topic, you will be comfortable with how to predict how the temperature, the surface area, and the concentration of something will affect the rate of reaction. All right, so first thing we got to know is when we're talking, what are we talking about when we're talking about a reaction? And in order to know that, we have to talk about what is a physical versus a chemical change. This may be something you're familiar with from previous years of chemistry. So to begin with physical changes, that is usually about physical states of matter, solid, liquid, gas, etc. Chemical changes happen on a molecular level and may or may not involve a change of state, change from solid, liquid to gas. When we're talking about molecules in chemistry class, we often refer to them as particles. Particles can refer to just any really small thing. More on that in just a moment. Everything is made of particles. Everything. You're made of particles. Everything's made of particles. And those particles just means any little bit of thing, any small thing is a particle. So you could have a piece of dust, a piece of glass, a grain of sand, or the way we're going to use it in these classes is a molecule or an atom. So if we take a solid object like this, the particles are the things that make it up, and there are just loads of them. Solids, liquids, and gases are made of particles, and those different types of particles can react with each other in different ways. Those reactions are where our chemical changes come from. So how can I tell whether it's a physical or chemical change going on? Well, if you have got a change of state, it's probably a physical change. If you have no new substance formed, so ice melting and turning into water, you had water before, you have water after, so you haven't made anything new. If you weigh it, you take the mass, you've got the same mass before and after, and you could reverse it. So if you take your ice and you put it in the freezer, you can reverse that change pretty easily. If you have a chemical change, the way you can tell that's happened is, has a gas been given off? Have you had a color change? Does it smell different? Did it get hot or cold? And can it not be easily reversed? The classic example of this is lighting a match. It gives off a gas. You've got a change in color from the yellow wood to the black carbon. It has a smell. It gives off heat, and you can't unburn a match. Eggs, cooking an egg is also this. You cannot uncook an egg. That is a chemical change. We are dealing with chemical changes in this class. Chemical change is also known as a chemical reaction because it is a reaction between more than one particle. And the time it takes for chemical reaction to happen can increase or decrease, i.e. it can go faster or slower. So basically, if we think about the egg, cooking the white of the egg goes from clear to white. That can happen quickly or it can happen slowly. And there are different ways to increase or decrease that speed at which it happens. That speed at which the reaction happens, the speed at which the egg cooks, the speed at which the match burns, is referred to as the rate of reaction. And that phrase is an extremely important one for this topic. Rate of reaction, the time it takes for a chemical reaction to complete. Here's a picture of some cars exploding. I forgot why I put this in here. Sorry. All right. So in order to have a chemical reaction, you have to have a collision between particles. That's why I put the cars exploding, because that's a collision. Those cars are colliding. In order to have a chemical reaction, you have some particles, some little tiny pieces of whatever is reacting, colliding, smashing into each other. And they make something new. So you have two little things smacking into each other and making a new thing. You end up with something different than what you started with. In this example, we have some hydrogen gas, H2, and some oxygen gas, and they collide, they slam into each other, and they make some H2O, which is water. So we've got hydrogen and oxygen combine, burn up to make water. Another example is calcium carbonate. That's limestone reacting with hydrochloric acid to produce carbon dioxide, water, and calcium chloride. So you probably will have done this before in a science classroom. You take your limestone, your calcium carbonate, you add some hydrochloric acid, and it starts bubbling away and kind of disappears eventually if you have enough acid. That's a chemical change. It's making bubbles, carbon dioxide gas, making water, which you can't tell because it's happening in water, and it's making calcium chloride, which dissolves. So those are two different examples of chemical change. I will be giving you guys some homework based on this video. Please do not hesitate to contact me if you have any questions.